Today we are going to learn about what is a very important tool in Java. And that is an abstract class. One person should read the definition on the screen for me.
An abstract class is an object-oriented programming. It's a class that cannot be instantiated on its own and serves as a template or blueprint for other classes. It's a way to enforce a certain level of abstraction in the design of a system. Here are some key points about abstract classes.
Okay, so an abstract class in object-oriented programming is a class that cannot be instantiated on its own. If I have something like this, system scanner UN equal to new scanner into brackets system.in. We've all seen this statement, right? We all know what this statement is. This statement allows us to put in or bring in data from our outside environment into our program. Now, the code you see here, where I've highlighted, right? Where I've highlighted is me instantiating my variable. So they are saying that if I have an abstract class, I do not have this section here. I can't do this section here. I can't instantiate values onto my object. I can't do that. So we will see that in implementation. It serves as a template or a blueprint for other classes. That means that if I have, for example, an application that I have to write a lot of code on, for example, I have employees in my organization, and my employees can be broken down into various categories, like contract staff, for example. Another example of employees I can have are the admin staff. Another example of employees I can have are lecturers. Another example of employees that I can have are commission. So here, let's say I have the marketers who are supposed to be here. So if we start January and we are saying our admission period is between January and April, the number of students you bring in is what I will pay you. So for every 100 students you bring in, I'll pay you X amount. Over here, we are saying that if you're a lecturer, you are being paid based on the hours in which you come. Over here, we are saying that admin workers have a 9 to 5 job, whereby they have to be at work from 9 and end at what? 5. And for contract workers, you are paid based on certain months in which we contract you to what? Work. Are we all okay? Hello?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Over here, all of these people are employees. So all of these people, I'll need their name, their date of birth, their next of kin, all of those information, I require them. But when it comes to payroll, each of these people will have a different payroll that they work with. So I will just create a payroll over here, and I will allow each of these people to have their own payroll based on their own environmental constraints. We will see an example of that. Now, how do we do this template? And let's start from this. Why do we even need an abstract class? So abstract classes are defined. Abstract classes are used to define methods that must be implemented by a subclass. The same way I showed you over here. Contract workers are a subclass of employees. So I can use the employee class to define it and use the contract class to take all of these properties and just add a modification that I'll be using in my program. Now, why is this important? And here is why it is important. This allows developers to define a consistent interface whilst permitting various implementations in different subclasses. That means that I can tell you, oh, for my organization, these are the things in which you require. How you will do them is your business. But whatever you do, you must have these things in them. Does that make sense?
Yes, sir, it does.
An example of an abstract class, because there is something called an abstract class, definitely there is something called an abstract method. So an abstract method is a method that is created without an implementation. What do we mean by a method without an implementation? If I say void display like this, the piece of information I am putting over here in this bracket here is my implementation. So if I call on display, the various sets of codes which will be executed in the two brackets there are the implementation of that method. So if I'm saying my method is abstract, then it means it has no what? Implementation. If I do this, then it is a concrete method, because a concrete method has an implementation. Without this, then it is not a concrete method, but it is an abstract method because it has no what? Implementation. So an abstract method has no implementation. A concrete method will have a what? Implementation. Let's see an example of this. I'll put on my IntelliJ. So I'll start a new project in IntelliJ. So I've started my application over here. I am trying to, 1 second. Where is the settings? 1 second. I'm trying to. Okay. I'm trying to make the font sizes bigger, okay? So that you guys can see. Or can you see?
Yeah, yes, sir, I can see, but I think I can help you with the font size. So you would have to go into you'd have to go into your settings. So there should be some three
Yeah.
bars on the right side of the screen.
I think editor, and then I go to general. And then in general, I go and look for,
No, you would need to go to the tab view and then go to appearance and then it will say Zoom IDE.
Zoom ID.
So you would have to close the settings. Oh, okay, actually, it says appearance and behavior. The tab that says appearance and behavior. So
Uh-huh.
click on appearance. Yes.
No, I think it is this one. If I take this one in the
Okay. It will allow
general,
you to scroll.
then it will allow me to use the mouse to,
Okay.
yeah, okay. Mhm. So over here, I'm going to create um, some few things here for the app in which I'm building. So I need to create a class for a class for animal. I need to create another class for dog. I need to create another class for cat. Okay. Now, my animal is going to serve as my abstract class. So here I have to remove the public from there and make sure it is what? Abstract. Now that I have an abstract class, I can create an abstract method. So here I have an abstract method called, which is of data type void, and the name is make what? Sound. So as you can see, this does not have an implementation. So over here, I have an abstract method. And here I have an abstract what? Abstract class. Class. Are we okay? Now, it does not have an implementation. If I did this, then it has an implementation, but it does not have any implementation. Now, this is a concrete method. A concrete method has an implementation. So here I can say void breathe. Again, an abstract class can have both concrete and abstract methods, like how I've just done on my screen. Now for dog, dog is going to extend animal. Animal. Which means that all the properties I have here in animal would be given to what? Dog. What kind of characteristic of OOP allows me to use the extend?
Inheritance.
Very good. So now I have inheritance allowing me to utilize the property of animals. That means that in here, I can use the overriding property of inheritance to tell the computer that I want to override there's something wrong. Yes, I want to override. And what am I overriding? The method to void make sound. Now, make sound, as we can see, is over here. Make sound. It has no implementation. So now in here, I am giving it its implementation, which is system.out.print ln into brackets. And in here, I want it to what? Bar. Over here too, I want to do the same thing for cat, which is going to extend animal. Also, I'm going to override and use meow here for cat. So in my main method, I can say animal. Are we okay? And then the object I want to use is my dog is equal to new. And what you guys would have done previously is say what? Animal over here. But you can't do that because an abstract class cannot be instantiated. Hence, over here, I'll say new dog. Now, this is okay. Why is it okay? You can see that in animal, it has all the properties that dog has. A red flag immediately would be, but sir, it doesn't have breathe. It has breathe. Why does it have breathe? Because it is inheriting everything from animal. That means that breathe is also what? Added. The only thing we did here is say, okay, since you already have make a sound, we want to modify it. So in the employee example I gave, every employee will have payroll, but it will be left to the classes that will be there, be it lecturer, be it a contract worker or whatever, for you to make the modifications on the payroll the person will get. So over here, this is perfectly correct. I can say animal, my cat is equal to new cat, that. And this is also perfectly what? Correct. So much so that I can say my dog dot make sound, or my dog dot breathe. Or I can say my cat dot make sound, or I can say my cat dot breathe. And these are all perfectly correct because of the way I utilize the class and I utilize the abstract class. Are there any questions?
No, sir. Yes, I feel like I understand it. So, for an abstract class to work, usually you would um, call its method by overriding it in a different class that has inherited the abstract class.
Mm-hmm.
Okay, so then if I were to let's say make a vehicle shopping or shopping system
Mm-hmm.
whereby I would need to have a truck or I would need to have a car um, be the subclass of vehicle class. That means in order for the car to move, I would have to make an abstract method saying that the car will move, and therefore I can allow the car or the truck to inherit it by overriding that abstract function.
Yes.
Okay.
Is that clear? If that is clear, then what is an interface?
I believe is an interface is an annotation that can be used to call specific methods. So basically, it would be a template to use within a class so that you won't have to reuse code, and you can use the interface to now develop certain objects or methods in a class.
You have the definition partially right. An interface in Java is a reference type similar to a class that can only contain that can only contain that can contain only constants, method signatures, default methods, static methods, and nested types. Interfaces cannot be instantiated. Fields. That is, you can't say something is equal to something or something will do something, none of that. Interfaces are just there for you to define what they are. Let's see an example of an interface in Java. So I'm going to create a new program again. I'm going to call my new program interfaces app. I'm going to create it. Yes, use this window. So in here, I'm going to create some things. First thing I'm going to create is the class called bird. I'm also going to create another class called eagle. I'm going to create another, but this time it's not going to be a class, but an interface. And I'm going to call it flyable. Now, in my interface, I'm going to say void fly. In my bird, I'm going to define what makes something a bird. And what makes something a bird is that they can make noise, so, which is going to be an abstract class, an abstract method, sorry, into bracket, make sound. And birds can also breathe. So system.out. Now, when I come to eagle, I'm going to do something a bit different here. So over here, I add extend bird. And we all know why I've added extend bird, because I'm telling you that bird is a parent to eagle. But I'm also going to add implements. Flyable. And here, the computer now understands that I am going to use information from an interface. And unlike extends, which can only be done once, with implements, I can implement from multiple sources. So over here, if I had another implementation, I could just bring a comma and tell you I'm picking from there too. That means that in my code over here now, I can pick information from the interface and the parent. That means that inside my class called eagle, I can say void make sound into bracket system dot out dot create ln into bracket screech. But this method here is already in my parent called bird. It's here already. So I have to tell the computer that I want you to override the one we have over there. Also, I want you to go and then take, that is public, void, fly. And when you take public void fly, I want you to say system.out.print ln the eagle soars high in the sky. But the problem here comes again, whereby fly can be found over here. So we are going to override the one in the implements. Now, in my main, I can go on to tell my computer that it should create an object of eagle, my eagle, being equal to new eagle into bracket. And in here, I can say my eagle dot breathe. My eagle dot make sound. My eagle dot fly. And if I run my current code, oh, sorry. Over here, I forgot to say that bird should be what? Abstract. Very well. What's going on? I can only implement when I'm in the main. So we can see breathing, screeching, and then soaring high are all over here for me. Now that we know implementation, we know extending and stuff, now we can build applications with all of these things in mind. I want you to also note something over here, that my computer is not giving me any error messages or anything. For example, here, if I do this and remove one, you can see that there's no error showing on my page. I get no notifications, nothing. Because the errors in my editor, I don't know why I clicked, they are gone. But you can see that the code I'm typing it raw. It's not giving me any colors, nothing. It's not giving me help when I do my eagle. When I do my eagle and I bring dots, it doesn't give me anything there, nothing. Those of you who are so reliant on the computer that you cannot function without these things, knowing the thing means you don't need those things. Those things are to help you. They are not there to be you.
Yes, sir.
Anything you don't understand from what is there right now?
Sir, I have a question. So an abstract, it can be a parent class. Um, yes. So an abstract can be a parent class, and then something like eagle can be a subclass of an abstract class.
Abstract classes are always parent classes. Abstract classes are always parent classes. Is that okay?
Sorry, can I have a look at the Flyable interface?
Sure.
So with this code, it is not going to end with any system send dot print ln.
No.
It's only going to appear. Okay.
Okay, no, it's not. Because with interfaces, you are just using interfaces to create, to define variables and define methods. Okay, so you see
Okay.
you see the idea is this. Let's say I'm working with 7 programs, right? All the 7 programmers, I have to have a way whereby I can tell them how I want my variables to be named, how many methods I want to use for my system, and how I want them to be like, to look like, what data types they should be. Because I have defined a database that has these data there. Are you following me?
Yes, sir.
I have a database of information. I, as the senior developer, I will define all the ways they would be. For example, let's say here, if this was an employee interface, I'll say string name, right? I'll say double
Yes, sir.
pay. I'll say get name. I'll say get pay. And all of these things are methods I am defining because they are supposed to be abstract by default. So by default, anything I put here is going to be abstract. So I will define the data type of the things which would be here, and so on and so forth. Now, when you come to implement this method, you would now go and define how you want the getting of the name to be done. So that if I call on get name, all I expect is a name that will be gotten.
Okay.
But you would go and do all the coding that would be done for the name to be gotten. So technically, I am hiding all the code away from you. That is why it is by default an abstract method, because abstractly, you would never know the implementations of the things going on over there. Because the implementations are not done by the interface, they are done by another class.
Okay.
So by default, an interface, you would never see an interface that has something like this there. No, because an interface is only going to have the abstract methods and the definitions of the abstract variables there. Finish. The way they will work and the way they will be done would be done by another class that is implementing that one. So you listen to the wording which is being used though. Over here, Eagle is implementing Flyable. That means in Flyable, you have a method there that has not been implemented. All that is there is the name. But its implementation is going to be done in what? Eagle. So you see that in Eagle, the implementation of the fly method is being done.
Mm-hmm.
So the interface's job is to define all the methods that are going to be used. Then when another class will go and implement that method in the way in which he sees fit. Keyword, he sees fit. That means I can have fly, but if I go and give the fly to a chicken, it will be a different way you fly from an eagle. Any more questions?
Okay.
let's look at the question and see how we would solve the question. The question starts from here. Create a fitness, or someone should read the question for us.
Create a fitness tracker application that allows users to monitor their physical activities and health metrics. Use classes such as user, activity, and health metric. Activity could represent various physical activities, like running, swimming, cycling, and include details like duration and calorie burn. Health metric could track data like heart rate, steps taken, and sleep quality. This system should demonstrate polymorphism by treating all activities as a generic activity type while allowing for the specific activity details.
I'm going to start a new application. We good to go?
Yes, sir.
Yes, sir.
Okay. So over here, based on the question that was given, I need to create a class called user. I need to create another class called activity. I need to create another class called health metric. Are we okay? Now, let's start from the activity. Now, activity is going to serve as the base class for all types of activities. So for every activity that will be there, it should be private, string, name. private, double duration. And then we have private, int, calories burned. Remember that activities is going to serve as our abstract class. And why is it serving as an abstract class? Because it's going to be the base for all other classes that pertain to activities. Public activity and in here, I'm going to create string or better still, let me just cheat with time a bit and then do this and use this to create the constructor. So I have public activity, string name, duration, and calories burned. And then I'll use this to set them at the top over here. Again, I would need getters for the name, duration, and the calories burned. So I'll use this again, and then I'll use the getter. I don't want getter and setter. I just want getters for this. So now I have getters for all of this. And then I need another one for public, abstract, void, performance, or perform activity. So this one means that it will be handled by the child classes of activity. With that said, now I can move to creating the various activities individuals will be doing. So now I can right click, go to new class, and create an activity for running. Now, under normal circumstances, running will have everything here. So instead of me coding everything here again, all I can say is that, oh, running will extend and have all the activities that would be in what? Activity. But I want you to add public running. And then in public running, we are going to say that it's going to have double duration added to it, comma, and then the int calories burned. So we have super. And remember, we did this super. Means me that this super here is referring to the constructor that is in the parent class. So super, the activity is running, comma, the duration is going to be duration, comma, and the calories is going to be what? Calories. This thing in which the computer is not helping me, I will suffer. I have to type everything. Oh. And then over here, I'm going to override public, void, perform activity, system dot out dot print ln, and in here I'm going to say you were running for space plus get duration plus hour, comma, burning plus get calories. Oh my God. Perfect. So I'll copy the code in here because I'll definitely need it for the other ones. And in here, I'm going to do another activity for the person. So right click here. I'll go for swimming. And then inside here, I'll paste it here. Of course, the activity is no more running, but it is swimming. And in here, we will have what here? Swimming. And then here, you were swimming for the duration of this, and then you burnt this number of calories. Okay. And then we will have another activity for cycling. And then in cycling, we have this. Are we okay? And over here, the activity we're doing was cycling. And we're cycling for this and that and that. And over here, it is going to change to what? Cycling. And then finally here, we're going to have what? Cycling. Great. Now, we can move to the health metrics. So under health metrics, what are the health metrics we'll be looking for in an individual? We are looking at the heart rate. We are looking at the person's steps taken. We are looking at the sleep hours. Public health metric. Okay, so this is going to be, I'm going to do cheat again over here, and then use, I'm going to cheat again over here, and then use the constructor to construct the constructor I want. And over here we have public void display metrics. System dot out dot print ln, and then in here I have the person's heart rate is going to be equal to plus heart rate. Plus the person's BPM. The person's steps taken is going to be plus steps taken plus that, comma, sleep hours plus space hours. Okay, we are done here. As you can see again, the editor that will be telling me if I'm making an error or anything has been taken away. So everything I'm typing here, I am making sure my errors are as minimum as possible. Minimum as possible. So now I can run this through, oh, having created user. So the user. So private string name private health metric is equal to health metric. So this health metric here is this one over here, right? The health metric I just created here. That is this one over here. So I'm creating the health metric as a variable. I'm using it as a variable. So we have public user. So over here, I'm creating a constructor for it. So I have health metric over here for me to use. Also, I'm going to have public void performance, oh sorry, perform activity into bracket activity and then small activity. Now, this activity here again is the activity I have here, and I'm using that as a variable. Instead of me using int or something, I'm using it as a variable. So I'm going to say system dot out dot print ln into brackets name plus the name of the person plus is starting activity, and in here we have plus here and activity dot get name. So it will go inside this code here, go and pick the name here. Again, it cannot have direct access to the name, so it will use this method here to get the name and show. When it is done, I want it to display the activity that it did. So activity dot perform activity. And then I'll stop it here. So again, it will enter here. That is activity. When it enters activity, it will go and look for the perform activity that is in the individual activities in which we have and use that. Okay. And we created the perform activity as an abstract class, which means that each of them has the ability to define the perform activity the way they want it. So in user, I've done this. In user, again, I will end by saying that public void display health metrics and say system dot out dot print ln name class comma single quote s health metrics is, and your health metrics is small h health metrics, and the small h is coming from display metrics. Okay, so this health metrics again is coming from the health metrics we have here, which is coming from the class health metrics here, and we are using the display metrics from here to display it over here. This application here shows how we are using polymorphism, abstract classes, inheritance. We are using overriding. We are using encapsulation to encapsulate all our work. We are making sure our work is secure. I am utilizing every single thing we learned for the whole semester in this code. So now, when I come to my main class, and I'm in my main class now, I can run all my code through the main class. And what do I want to run? I want to create a new user. So my user is going to be called user, and it's going to be equal to new user. Great. Now, for a user to be created, are we all okay? For a user to be created, there are some things in which the user needs. What's the first thing the user needs? He needs the name. So we have here Kofi main. Now, over here again, this Kofi main is a constructor. So you can see that I'm using the constructor I did here to construct my user menu. And what does it take? It takes a name and it takes the object health metrics. That means I have to tell the computer that we are creating a new object, which is what? Health metric. And health metric also takes in some pieces of information. What does it take in? It takes in health metrics, it takes in the, oh, here it's supposed to be heart rate. I spelled it wrong. That means every place here I have to add it. Let me add a T. Great. So it's supposed to be heart rate, right? So over here, I'll enter the person's heart rate as an integer. So let's say 72, comma. The next thing in which health metric will take would be the number of steps the person has used for a day. Let's say he uses 1,000 steps a day. And the last thing in which health metrics will take is the sleep hours of the person. So how many hours did the person sleep? So in my main method again, I'll bring comma, let's say for 8 hours. So now I have all the information I need for me to create a user. So I've created a user. And you can see how I am combining the classes and the objects together, because the user goes with the health metrics. So now over here, whenever I call on user, I have a user who has these health metrics already configured already. Every statement in programming ends with semicolon. So I end mine with a what? Semicolon. Again, as you can see, if I didn't bring the semicolon, but it hasn't underlined anything as an error, because all the errors are taken away for some reason. And I'm still writing my code. No errors, no nothing, no spelling mistakes, nothing. My activities. What activities did the person perform? So activity, one second. Sorry about that. I had a call, sorry. Activity running is equal to new running into bracket 1.5, comma 300. Again, note how the base class is being used, activity, but it is an abstract class, so it cannot implement anything. So over here, we are using running to implement it. I need to do this for women. And cycling. Remember, the ones with S are just variables. With small letters starting are just variables. The one with capital letters are the classes in which we defined. So swimming, now cycling. So for a particular user dot performance, are we okay? Of an activity. And I said that the user is performing the activity of, let's say, running. This piece of code can tell me his rate and things he was doing when he was running. And I can also show you the user's metrics. You see, this is the implementation phase. So you as the user, remember here we have an interface. We can pick the data from a form. We can pick the data from a console screen. We can pick the data from multiple screens. It doesn't really matter. And we will look at that, how we can do a small form, pick the data from there, or pick from console. It really doesn't matter. What matters is that in the implementation phase, all the person will see is this piece of information. You want to create a user, all you need is the user's name and his health metrics information. You want to say the person is running, all you need is how many what is the duration in which the person is taking, and what calories is he burning. That's all. Abstraction of data is working. Encapsulation, how the information is being stored, where it is being stored, how it is being done, you do not care. All you do care about is when I click on this button here, hopefully, if I have no errors, hopefully, I have one error over here. So let me see where that error is. Oh, it is here. I didn't add the semicolon at the end. So I've added it. Let me see if I have another error. Okay, so I have another error here. I didn't bring the L here for public. So I have done that. Again, you see how I am correcting my errors. I'm not calling CERMAC. I have error. I run it again. I have another error here. Or if there's an error here, then there will definitely be an error over here because I did copy and paste. So let me see if I can solve all of them immediately. Oh, and here too, I did copy and paste. So if I did copy and paste, that's why sometimes doing copy and paste is not good, because if there's an error at one place, there will most definitely be an error in all the other places. So now that I've handled that, sorry, let's run it again. Oh, again, another error. So let's see, what did I do wrong here? Invalid declaration type. Okay, so here, the S here is supposed to be capital, but I think I made it a small s when I was doing the swimming over here. Yes, I did. What I'll do is that I will copy the code in here, I'll cut it, and then I'll come and delete the swimming. And then I'll go and create the class again to swimming. And then I'll just come and paste it here so that everything will tally. Run again. I didn't bring a semicolon here, so I've done that now. Run again. Okay, so now I have some more. Again, you can see how I'm solving my errors. Oh. Karen, Ali, I wouldn't keep the error
Yes,
for
sir.
a week. Karen. Over here, I have this error here. Why do I have an error here? There is no. Okay, so it's giving me an error because I didn't add extends activity over here. I didn't extend it to the parent. So let me see if I did it here. I did it for swimming and I didn't do it for this. So let me see, extends. My computer has frozen. One second. Okay. So I only need this. So now I can come back to it. So, okay. So now, yes, here I saw it. It's supposed to be T here because over here I added T here, so it's heart rate. Here again. Sleep hours. So here P. Again. Have no more errors. Let's see what the computer is telling us. So we started our code here in line 3. We said we gave it 75, that as our matrices. That is our heart rate, steps taken, and hours that the application has slept. So over here, Kweku Menu has started the activity of running. So we can see it here, okay? When we picked it, running. So he has started the activity of what? Running over here. Okay, that's great. So once he started the activity of running, he what? He ran for 1.5 hours, which is true here, 1.5 hours. He burned 300 calories, which is true. He burned 300 calories over here. Over here to Kweku Menu's health metrics, he has a heart rate of 72. You can see that here it is true. He has a heart rate of 70. He has the steps taken of 1,000. Yes, he has steps taken of 1,000. And his sleep hours are 8 hours. So we can see that, yes, his sleep hours are. So we can see that everything we wrote has manifested. You understand? And this is how we would create various objects. We would be merging our code going forward. We'll be using all the implementations we have learned going forward to build applications that meet the standard of object-oriented programming language. Are there any questions?
No questions from you, sir.
When I was a student in school doing my undergraduate, to be honest, programming courses I did very well. Can't lie. I can't come and sit here and lie. There are courses in which I despise them, like networking. When I say I did not do well, it means I got like BO, not you people that do well, people think of. And like accounting, economics, these courses, I didn't really do well. But the programming courses, to be honest with you, I did very, very well. The only programming course I did not do well was Java. Java has always been difficult. Always. Now, you may not look it, but Java has always been difficult. So I take Java very seriously if I was you. Because of the whole object-oriented nature, the principles we have to learn, and so on and so forth, I take it very, very seriously. You must practice. You must put in more effort. You must dedicate in more time. Other than that, if the midterm is anything to go by, the exam will not be that good. And I've already told you, I will not add any marks to you. If it is 2 you get, I'll give you 2. Thank you for showing up. We'll meet again next week. I will send you the recorded video by the end of the day.
Thank you very much.
Bye-bye.